So here at Clemson, we're looking at the debris impact resistance of cross-laminated timber. We do this because in the event of a tornado or a hurricane, there's windborne debris, and often that debris is in the form of 2x4s, and so we shoot those 2x4s at different materials to determine their response and how well they protect you against those hazards. So in the event of a tornado or a hurricane, there's wind-induced pressures on the structure, and those pressures produce forces. But in addition, there is an internal pressure that builds up if there's any punctures or penetrations in the facade of the building. And because of that internal pressure that builds up, there's often roof failure, which leads to roof trusses and wall studs becoming airborne, producing debris that can put penetrations in other structures. So one of the values of performing this research now before it's a widely used building material is we can determine the properties, the structural properties of this material, whether that's the bending strength or the stiffness of this material. We can then use it in structures and understand its properties. We also use a variety of different sensors to measure the impact of the panel. We use load cells to measure the force that's transferred from the missile into the panel, as well as accelerometers and displacement measurement sensors to measure both the acceleration and the displacement of the panel under testing. So some of the things we record through these tests are the indentation of the missile. This was caused by a 15-pound missile at about 80 miles an hour. And we see that at different locations there's different response of the panel. At the center, there's often a lot more elastic deflection. At the edge of the panel, we see a lot more inelastic deflection and more indentation. And that's because the panel is not as flexible when we shoot it near the edge. When we shoot it near the center, it's allowed to deflect and absorb a lot more of the energy.